about surface chemistry in gaseous state, what could be the reason? Can we just interact also? So what would be the reason? Surface. It would be possible only on solids and liquids. But you won't observe any surface chemistry on gaseous state. Or you can say on gases. There is no surface chemistry on gaseous state. The reason being, we know gases are completely miscible with each other. So they will lead to the formation of a homogeneous mixture. Homogeneous means you cannot, exactly, uniform. We cannot distinguish between one gas molecule from the other gas molecule by just looking at it. But when we talk about solids and liquid, we can say this table is solid in state. The water in this bottle is in liquid state. So surface chemistry is basically observed on surfaces. We should have a surface so that some kind of a chemical reaction can happen on the surface. Would you like to take notes also? So right, I'll just give few definitions. Uske baad I'll explain you what is that. Okay. So right now it's a branch of chemistry which deals with the. It's a branch of chemistry which deals with the study of phenomena occurring at the surface or the interface. Occurring at the surface or the interface. Okay, I think you guys are clear with the surface part. Now what do we mean by interface? Interface is a place where you have two different bulk phenomena or bulk properties are interacting with each other. That means if I take two solid and I make it interact with another solid, so this layer which is formed during the interaction of the two solid would be the interface. Similarly, you can have this interface when you make your liquid interact with the solid surface. So when you're talking about two different phases, or these would be your bulk phases, so you represent them with the help of either hyphen, okay, this is hyphen, or you can use slash, just to distinguish between the kind of a phases present in the reaction in which you are interested. Okay, okay, I think with this you guys are clear with the concept which is your surface chemistry. Okay, okay, now we'll start with adsorption in detail. So the term adsorption being a part of a surface chemistry, it's basically a surface phenomena. So you can write it's a surface phenomena. That means in adsorption what we do, we study the reactions which are happening at the surface of a solid or liquid. Gases pe we don't observe any adsorption because of their homogeneous nature. This is clear to everyone? Okay. So in adsorption what we see that solid and liquid have a tendency to absorb molecules or any substance on their surface. This accumulation of the substance on the surface is known as adsorption. Okay, so you can write down the accumulation of the molecular species. The accumulation of the molecular species at the surface rather than the bulk of the substance is known as adsorption. So in this definition you can see that we are using two things. One is the accumulation of the substance on the surface. Okay, let me say you have a solid, okay, on which you are accumulating your substance or any molecular species. ठीक है, it will accumulate more on the surface. Or just to make it more clear, I'll just take a rectangle and the molecular species will get adsorbed on the surface. They won't go into the bulk. Bulk means we're talking about within the system, into the system. ठीक है, surface means we're talking about the surface. So this accumulation at the surface is known as adsorption. Now we use two terms. The molecules which are getting adsorbed on the surface are known as adsorb. I heard this word from you, just say it loudly. They are known as adsorbate. ठीक है, and the solid or the liquid on which the adsorption or accumulation or you can say concentration of a substance is happening is known as adsorbent. Good. ठीक है, so you can say adsorbate means the molecular species. Adsorbent means the molecular species or a substance which accumulate or concentrate at the surface. ठीक है, you can say concentrate at surface. ठीक है, adsorbent means the surface on which this accumulation or concentration of the substance is taking place. ठीक है, so adsorption, if I want to sum up this adsorption, what we can say, adsorption is a surface phenomena or the reaction happening at the surface of the solid, and the thing or the substance which are getting absorbed are known as adsorbate. Surface on which this adsorption is taking place is known as adsorption. These three things are clear to everyone? Second and the third term. ठीक है, यहाँ तक clear है सबको? Any doubt? Okay. Proceeding further, like अभी तक whatever I have said is more about the surface. I'm emphasizing more on this word surface phenomena. So what is this special thing about the surface which is not in the bulk, that molecules are sticking just on the surface and they are not getting into the bulk of the solid or the liquid? There should be something special about the surface. That's why the reactions are happening only at the surface. So now we're going to study what is this special properties. Okay, I think you guys know residual forces. What are residual forces? Say yes or no at least. No? Okay, fine. So write down. We'll see the mechanism of adsorption. How does your adsorption takes place? Okay. First, let us consider a liquid. I think you guys are aware what is a liquid. ठीक है? Now, if I consider a molecule within the bulk of this liquid, ठीक है? So it would be, let me say this is the molecule in the liquid, so it would be surrounded by the other liquid molecules in all the directions, right? ठीक है, we know molecules interact with each other, there will be forces of attraction on it, so it will be attracted by this molecule, so there will be a force of attraction between these two molecules. Similarly, this molecule would be attracted by this molecule, so there would be a force of attraction, but the total force on this molecule because of the force of attraction, but that force of attraction is there in the opposite direction, so the net force of attraction on this molecule would be 0. Similarly, if we say this molecule, so it would become 0 because it is there on the both side. If we say this, these molecules, here also it becomes 0. Similarly, these two molecules. So what you can say, when a molecule in the liquid is in the bulk of the liquid, it will experience what? When the molecule is in the bulk of liquid, you can say no forces of attraction. ठीक है, forces of attraction are there but they get cancelled by the same force in the opposite direction. Clear? Okay, now let us consider another molecule. This is one molecule which we have talked here. Let us consider the one molecule at the surface of the liquid. ठीक है, what happens if we say this is the surface and this is the liquid molecule in which we are interested? So it would be surrounded by the liquid molecules on the liquid side. Let me say like this. ठीक है, इस तरीके से होगा. Clear? So it will experience forces of attraction. But above the surface of the liquid, what you have? Air. Or if that liquid vaporizes, so it will have some vapors of this liquid, but that would be less as compared to the molecules of that liquid in the bulk. So here also you will have the forces of attraction, but that would be less as compared to the one which is present in the bulk. ठीक है, यहाँ पे जो forces of attraction होंगे वो ज़्यादा है as compared to the one which are present at the surface. So what we are observing here, the forces of attraction are there at the surface but not in the bulk. ठीक है, so these forces of attraction which are not getting satisfied are known as residual forces. So now you know what are residual forces. Clear to everyone? It is because of the unbalanced forces of attraction or the interactions at the surface of the liquid we get residual forces, and it are these residual forces which are responsible for the interaction of adsorbate and adsorbent. If they are not there, residual forces are not there, we won't observe any surface chemistry, or you can say we won't observe any adsorption. Clear? This is in the case of a liquid. Let me consider a solid molecule. We know the molecules in the solid or the atoms in the solid are closely packed. ठीक है, so there would be atoms at the surface also and in the bulk also, right? But they are held by very strong intermolecular forces. So similar the way we have seen that the molecules in the bulk experiences no forces of attraction, same is the case with the solid, and the molecules at the surface will have residual forces, but in case of solid you can call them as free valencies also. ठीक है, in case of solid you can call them as free valencies or unsatisfied valencies. Free valencies or unsatisfied valencies. So it is because of these free valencies or unsatisfied valencies your solid is able to allow adsorption to happen. If it is not there, you won't absorb any adsorption. Clear? So now you can understand what is the mechanism of adsorption. It is because of the presence of residual forces or free valencies or unsatisfied valencies which leads to the adsorption of adsorbate on the adsorbent. Right? Clear? Now one important thing I would like to mention here is that along with the residual forces, one more thing when you are talking about a solid is that since it is a surface phenomena, higher the surface area, you can write down this, higher the surface area, higher would be the adsorption. Higher the surface area, higher would be the adsorption. So if I break this solid molecule into smaller particles or smaller solids, what I get? Atom or the solid molecule with more number of free valencies. ठीक है, that means breaking up or finally dividing the metal into small or powdered kind of a structure will give you more free valencies or unsatisfied valencies. So the surface adsorption would be more in case of finely divided metal or a solid which you are using for your surface chemistry. Clear till here? Okay. There are few more terms I would like to discuss here are along with the adsorption is that when you are allowing adsorption to happen, that is adsorption. When a molecule is getting concentrated at the surface, that is adsorption. But when you want to remove that molecule from the surface, what do you call that process? Desorption. Very good. That process is known as desorption. Okay. So it is done by simply evaporating or by increasing the temperature of the system. But that is possible only when you're talking about physical adsorption. When that we'll discuss in details when we'll come to physical adsorption and chemical adsorption. So there are simple procedures to cause desorption to happen in the physical adsorption, but in case of chemical adsorption, the process of removal is bit tedious. You have to apply certain harsh conditions on the reactions. Okay. Then the next topic, just write down. You guys must have heard of absorption. Yes? What is the difference between adsorption and absorption? Adsorption. Okay? And the second word which I am saying is absorption. ठीक है? Adsorption is the same in both adsorption and absorption. It is the word AD or AB. Adsorption, I believe it's clear to everyone. Absorption, you guys must have an idea. Absorption is basically a bulk phenomena. Adsorption is a surface phenomena. Absorption is a bulk phenomena. That means the concentration of the molecules is more at the surface. In this case, we cannot say it is more at the surface or more in the bulk. It is uniformly distributed within the bulk of the system. Okay? The concentration of molecule would be same at all the places. We cannot differentiate कि here it is more, here it is more. It is evenly distributed. So adsorption is a surface phenomena. Absorption is a bulk phenomena. Second thing is that there are certain cases when your adsorption and absorption takes place simultaneously. There are certain reactions in which both the process takes place. For example, let me say you have a colored water. Okay? If I want to represent the colored water, let me say you have a colored water. Okay? I add a chalk piece into it. Chalk, you know what is chalk? So what happened during that, the dye molecules of this colored solution, they get adsorbed on the surface of the chalk, whereas the water, if I say the dye is made in water, water molecule gets into the bulk of the chalk. So in this case, what is happening? Your adsorption and absorptions are taking place simultaneously, and such processes are explained with the term known as sorption. Sorption means when your adsorption and absorption takes place simultaneously. Clear to everyone? If I want to give one more example, let me say you have a system consisting of water molecules and I add silica gel and aluminum chloride molecule. Okay? This is your silica gel and aluminum chloride molecule. So what happens? The water molecules get adsorbed on the surface of silica gel, whereas in case of aluminum chloride, the water molecules get absorbed in case of aluminum chloride. Okay? So your adsorption and absorption are taking place, but in this case the adsorbent is different. One is the silica gel, other one is your aluminum chloride granules. Clear to everyone? Right? Okay. Sorry? ओके ठीक है. Okay, we have talked about residual forces of free valencies. There's one more thing important in the adsorption is your heat of adsorption. Heat of adsorption means we denote heat generally by this symbol. Delta means the change in the heat, right? This is known as enthalpy. You guys know enthalpy? What is enthalpy? It is the amount of heat released or absorbed during the reaction. If it is released, then that reaction is known as exothermic reaction. That reaction is known as exothermic reaction. Now the majority of the adsorption reaction are exothermic nature. That means your delta H is negative. So that if I want to represent this reaction, it would be A plus B is giving you product with some amount of heat. But when you represent this, so instead of plus sign, what we prefer? Minus. That means this heat is released. And there are some reactions which are known as endothermic reactions, in which your delta H is positive. That means you have to give some heat to the reactant so that they can get converted into products. Okay. First is your enthalpy. Second one is your entropy, represented by this symbol. Delta means we are talking about the change in the entropy, because always when we are studying any reaction, we are interested in the change which has happened due to the reaction. Now entropy is randomness or disorder. ठीक है? In our case, in adsorption, you have residual forces. That means that adsorbent has high amount of entropy. That means the degree of disorderness or randomness is very high. Sorry, entropy is basically accounted with the randomness of the molecules. Now how you can relate these two with each other? With the help of delta G. Very good. Delta G is related to enthalpy and entropy through this reaction. Okay. Now for any reaction to be spontaneous, the first condition or the most important condition is this, that our delta G should be negative. अगर delta G negative है, if the delta G is negative, that means the reaction is spontaneous in nature. If it is positive, that is non-spontaneous. Very good. And if delta G is 0, this means a system is in equilibrium. Now we'll talk about spontaneous reactions. Okay, we know our solid has residual forces. That means they have high amount of entropy. Entropy is very high when there is no adsorption. We just have a solid molecule or a liquid. There is no adsorption. Entropy is very high when there is no adsorption. When you allow adsorbate molecules to get adsorbed on the adsorbent, what happens? These residual forces or free valencies or unsatisfied valencies get satisfied. Residual forces become complete. They get balanced. So what happens to entropy in this case? It decreases. So during adsorption, what happens? Your change in entropy, if entropy is decreasing, your change in entropy would be negative. Good. Okay. Now we want a reaction to be spontaneous. For that, delta G should be negative. Now this is possible only when, if this is negative, negative into negative becomes positive. If our delta H is positive, delta G will become positive. So if we want a reaction to be spontaneous, delta G should be negative. This is possible only when you have delta H with a negative sign. That means the reaction is in highly exothermic state. Then only you will have a spontaneous reaction. Am I clear to everyone? You want me to revise this again? we are interested or we observe enthalpy change and entropy change during the course of the reaction. Entropy decreases because during adsorption you have adsorption of the adsorbate molecules on the adsorbent. This leads to the decrease in the entropy. So the overall entropy change for adsorption becomes negative. Now according to this equation, if we say that delta H can be positive, we assume it can be positive, but if entropy is negative at constant temperature, this factor becomes positive. So the overall free energy change becomes 0, which will lead to a non-spontaneous reaction. Okay, which will lead to a non-spontaneous reaction. So that a reaction to be spontaneous, we should have delta H in a negative sign. That means it should have a negative value, or the reaction should be highly exothermic. Then only we can have our spontaneous reaction. Clear to everyone? So with this we can say delta H should be negative. So the conditions for adsorption, thermodynamic parameters for the adsorption becomes that enthalpy should be negative and entropy is negative. During the course of the reaction, entropy decreases. Initially, when you are like beginning the reaction, enthalpy of the reaction is very high when the valencies are getting satisfied. But during the course of the reaction आपका proceed कर रहा है, during the course of the reaction, will the enthalpy remain same or it will decrease? It will decrease. Yes, absolutely correct. During the course of the reaction, since you will reach a stage where all the residual forces will get completely balanced, or the reaction is happening during the course of the reaction, your delta H will keep on decreasing. That means it is moving towards a positive value. So a stage will come when this factor will nullify this factor and your delta G will become 0. So this stage is known as equilibrium. Reaction won't go into a positive state. That means that is a non-spontaneous reaction. That won't happen. Your reaction would stop here. Stop here means the rate of the forward reaction becomes equal to the backward reaction. And you will have an equilibrium between adsorbate and adsorbent. Equilibrium in the sense means the rate at which the adsorbate molecules are getting adsorbed will become equal to the rate at which they are getting desorbed. Okay, so I think this parameter is clear to everyone. Any doubts? Okay, fine, good. Now we'll see that there are certain factors which are responsible for adsorption to happen in a feasible direction or a direction in which we are interested. The factor is like, let's start with, first factor is the nature of adsorbent. Factors affecting adsorption. The first factor is your nature of adsorbent. Okay, nature of adsorbent means some gases get adsorbed to a different extent on the same adsorbent. For example, let me say that you are absorbing a different gas on charcoal molecules, so they will get absorbed to a different extent. The reason being, in case of gases, I think you know what is critical temperature. What is critical temperature? Represented by this symbol. Critical temperature is the minimum temperature required to cause the liquefaction of the gas. ठीक है? Critical temperature is the minimum temperature to required to cause the liquefaction of the gas. Higher the critical temperature, more easily the gas will get liquefied. Higher the critical temperature, more amount of gas would get adsorbed. ठीक है? So nature of the adsorbent means 1 gram of charcoal अगर आप लेंगे और उसके ऊपर अलग अलग गैस एड्जॉर्ब कराएंगे, तो दैट वुड डिपेंड अपॉन द काइंड ऑफ द गैस यू आर गेटिंग एड्जॉर्ब्ड, विच डिपेंड्स अपॉन द क्रिटिकल टेम्परेचर ऑफ द गैस. जिस तरीके से वो आपका चेंज करेगा उसी हिसाब से आपका नेचर ऑफ एड्जॉर्प्शन विल चेंज. सेकेंड इंपॉर्टेंट थिंग विच कम्स हेयर इज योर surface area. Higher the surface area, higher would be the adsorption. Higher the surface area, higher would be the adsorption. So nature of adsorbent and the surface area are the important factors when you are studying an adsorption. Second factor here is your temperature. Okay, so during adsorption we know heat is released. Initially when you are saying no, effect of temperature is generally, abhi I want you to just understand that adsorption decreases with increase in temperature. So you can write it down this as adsorption decreases. I'll use this sign. Decreases means it is getting decreased with increase in temperature. We'll see the reason later when we'll talk about physisorption and chemisorption. Abhi ke liye it is just that adsorption decreases with increase in temperature. We can discuss one factor here is that delta H is negative in case of adsorption process. That means high amount of energy is getting released during your adsorption. Now when you increase the temperature of such reaction or the exothermic reaction, what happens? The reaction will respond in such a way that increase in temperature should get compensated. By compensated would mean that it should not keep on increasing the temperature of the system. That heat should be utilized. We don't want bombardment or the explosion of a reaction system. The temperature which we are giving to our system should get utilized. Now let me say I consider H and B, they are the reactant molecules combining to give you a product molecule and some amount of heat is released. Reaction is already heated up. Okay? When you give the temperature, when you are increasing the temperature of the system, that will lead to the further increase of the reaction mixture. So the reaction will move in a direction where that temperature can be taken care of. Taken care of means if you are increasing, that during the reaction that temperature should decrease. If this reaction is exothermic in a forward direction, then it would be endothermic in a backward direction. So when you increase the temperature of the reaction becomes backward. Okay? Or you can say the rate of the backward reaction increases. I'm clear to everyone? Temperature, with temperature adsorption decreases. With increase in temperature adsorption decreases. Why? Instead of going in a forward direction, your reaction now takes place in a backward direction. That is happening just to compensate for the increase in the temperature. Clear to everyone? Now the third factor is your pressure. Okay, with pressure, or you can say with increase in pressure, your adsorption increases. With increase in pressure, your adsorption increases. Now what do we mean by pressure? Forces exerted on each other. That forces are measured in terms of the pressure. Now that forces between the gaseous molecule is responsible for the pressure of the gaseous system. When you are increasing the pressure means the forces of interaction between the gaseous molecules are increasing, or you can say the number of the gaseous molecule is increasing. Okay? Two possibilities are there. Either the interaction between the gaseous molecule is increasing or the number of the gaseous molecule is increasing. Since the number is increasing, let me say the number of the gaseous molecule is increasing, the reaction will go in a direction where this number decreases. Let me say you have one A molecule and you have two B molecule. One A matlab single A atom and two B atoms. They are combining to give you two AB matlab two product molecule. So the net change in the number of molecule is, if I want to say delta N, what would be? 2 minus 2 plus 1 becomes, that means the number of molecules are getting decreased in the forward direction. So when you increase the pressure, reaction starts taking place in a forward direction. That means reaction will take place in a direction where the number of the molecules decreases. Why I am saying number of the molecules? Because pressure is due to the molecules only. The number of molecule increases, the pressure increases. To decrease that, reaction should move in a forward direction. So now you understand nature of adsorbent and surface area, how they are responsible for adsorption. Surface area increases, adsorption increases. Temperature increases, adsorption decreases. Pressure increases, adsorption decreases. Okay. Okay. There's one more factor in this which is known as activation. By activation we means we are making our surface to be more active. Sometimes what happens, like we want to see adsorption reactions at the surface. Since they are taking place at the surface only, the surface of the solid or the liquid should be very clean. They should not have any impurity over them. If the impurity is there, then that impurity will act as an inhibitor, or they will stop, or they will decrease the rate of your reaction. So to avoid that, what we do is we activate our which molecule? Adsorbate or adsorbent? Adsorbent, the surface on which our adsorption is happening. So activation means you generally heat your adsorbent system in a vacuum at a very high temperature, so all the impurities will get desorbed. Okay? Surface becomes available for the reactant molecule so that your adsorption can take place. So you understand now what is activation? Activation is a process through which you make your surface available for adsorption. You make your surface available for adsorption. Second, ये तो हो गया temperature, how temperature is used. Another method is like you divide your solid molecule into a finely divided powder form. In this way, you are increasing the surface area of your solid. Okay? You divide a solid molecule into a finely divided powder. In this way also you are activating your adsorbent. That means the number of the active sites or the residual forces increases. Activation means a process through which we can increase the rate of adsorption. Okay? This is clear? Hanji. How critical temperature affect adsorption? Okay. तो मैं supposed to explain this first ना, और बाद में भी कर सकती हूँ. Because I'll be discussing that. I'll take up this question later, how critical temperature is responsible for adsorption. We'll discuss this in details. Okay, after that, adsorption, the last topic in your adsorption is your type of adsorption. ठीक है? Now to do that, I want you to tabulate this. There are two kinds of adsorption. One is physical adsorption. Another one is your chemical adsorption. Physical adsorption is also known as physisorption. Similarly, chemical adsorption is also known as we'll discuss them in details. As the name suggests, first we'll just focus on the word with which we are interested and about the word with which we are talking. Physical adsorption or physisorption, something physical in nature. Okay. Chemical adsorption, some kind of a chemical reaction is there. That means you will have a formation of chemical bonds, and that chemical bond can be covalent or ionic in nature. Very good. Now, starting with first point is your kind of forces. By kind of forces means when we are saying physical adsorption, you have van der Waals forces in all kind of molecules. Van der Waals forces are the weak force of attraction between the molecules. So physisorption is there because of the presence of van der Waals forces. So you can say that physical adsorption is due to the presence of van der Waals forces of attraction between the, whenever I'm saying between the, that means we are talking about adsorbate and adsorbent, okay, between van der Waals forces of attraction between the adsorbate and adsorption. When we are saying chemical adsorption, the kind of forces will become strong forces. Strong forces are your covalent forces or ionic forces. So these reactions or chemisorption is due to the chemical reaction between your adsorbate and adsorbent. It is due to the formation of the chemical bonds between adsorbate and adsorbent. Since you have a formation of a chemical bonds, whenever a chemical bond is formed, you have high amount of release of energy. So during this, high amount of energy is released. So during the formation of a chemical bond, high amount of energy is released. So it is because of that high amount of energy, it is also known as activated adsorption. It is also known as activated adsorption. Clear? Why it is called activated adsorption? Because during the formation of chemical bonds, high amount of energy is released, and that energy also increases the rate of the reaction. That is why it is called activated adsorption. Now this difference is due to the kind of the forces. Second difference is on the basis of specificity, let me say this is 1, this is 2. This is forces and this is specificity. By specificity means specific, मतलब एक particular reaction के अंदर we are interested. Since here van der Waals forces are present in all kind of molecules, so physisorption is not specific in nature. Okay, physisorption is not specific in nature. Whereas in case of chemical adsorption, you have the formation of chemical bonds, and it is possible only when you have some kind of a free valencies at the surface, and some kind of a chemical reaction can happen between the adsorbent and adsorbent. Okay, bond would be covalent, matlab they will share their electrons to form a covalent bond. If I'm saying ionic bonds, that means either it will take up the electrons from the surface of the solid or it will lose the electrons at the surface of the solid, so that the bond formation can happen. So if there is a tendency to form a bond, the sharing of the electrons or losing or absorption of the electron is there, then only you will observe chemical adsorption. If it is not there, then that kind of adsorption will become your physisorption. Clear? Specificity means if there is a tendency for the formation of bond, if bond is getting formed, bond can be ionic, bond can be covalent, but bond should be there. If it is there, you will call that adsorption to be chemical adsorption. If bond is not there, adsorbate molecule just held over the surface due to the weak forces, then that adsorption will become physisorption. Clear? So that is why chemical adsorption is specific in nature. Okay, this is clear to everyone? Non-specific in nature, this is specific in nature. Why specific? Because there should be tendency for the formation of the bond. Third is reversibility. By reversibility we means that we should be able to reverse our reaction. That means we should be able to get our reactants back. If it is possible, then that reaction will come under your physisorption. Since physisorption, the molecules are held by weak van der Waals forces, it would be easy to disturb those forces. So physical adsorption is always reversible in nature. Whereas chemical adsorption, the atoms or the molecules are held by chemical bonds at the surface, so it would be non-reversible or irreversible in nature. Clear to this? Why we are calling this reversible? Why we are calling this as irreversible? Since the molecules or the atoms are held by weak van der Waals forces and it is easy to disturb those van der Waals forces, physical adsorption is reversible in nature. Whereas since the molecules in chemical adsorption are held by strong chemical forces like ionic bonds or a covalent bonds, it is not easy to disturb those bonds. If you want to disturb that, you are supposed to give high amount of energy to the system, which is not feasible easily. That is why your chemisorption is known as irreversible in nature. Second, the fourth point is temperature. Now these points will help you to remember the difference between physical adsorption or chemical adsorption. If you just remember this, I think you will be able to tabulate all the differences easily. Okay, temperature. With increase in temperature, your physical adsorption decreases. Okay. Similarly, with increase in temperature, physical adsorption decreases. Okay. But the chemical adsorption is possible only at high temperature. So with increase in temperature, your chemisorption increases. Okay. Increase in temperature, your chemical adsorption increases. Okay. Okay. Since these are held by weak van der Waals forces, next is the enthalpy of adsorption. They have low enthalpy of adsorption. As they are held by weak forces, they have low enthalpy of adsorption, which is in the range of 20 to 40 kilojoules per mole. Whereas in case of chemical adsorptions, since they are held by chemical bonds, and whenever there is a formation of chemical bonds, high amount of energy is released. So they have high enthalpy of adsorption in the range of 200 to 80 to 200 kilojoules per mole. Sixth would be your nature of adsorbent, in which you have two factors. One is the nature, another one is your surface area. Higher the surface area, higher the adsorption. Here also higher the surface area, higher the adsorption. It is same in both the cases. More the surface area, more is adsorption. This may be same. More the surface area, more is the adsorption. Okay. One question which blinked during this is your critical temperature. Seventh, which depends upon the nature of gas which is like getting adsorbed. Okay. Critical temperature. I want you to write down first. Critical temperature is the temperature at which critical temperature is the minimum temperature required. It is the minimum temperature required to cause the liquefaction of the gaseous molecules. Critical temperature is the minimum temperature required to cause the liquefaction of the gases. higher the critical temperature, more easily is the liquefaction of the gas is possible. You can easily liquefy the gas if critical temperature is high. Okay. The easyability of that gas to get liquefied, जितना ज़्यादा वो easy होगा उतना ही easy would be for that gas to get absorbed on the surface. ठीक है, that means higher the critical temperature, higher would be the absorption because liquefaction is possible easily. It is clear what is critical temperature? Minimum temperature to cause liquefaction. Higher the critical temperature, more easily the gas can get liquefied. Now let us consider an example. Let me say you have 1 gram of charcoal on which you are absorbing 3 different gases. First is your sulfur dioxide, second is your methane, and the third one is hydrogen. Now let's first talk about their critical temperature. Critical temperature in case of sulfur dioxide is something of the order of 630 Kelvin. In case of methane it is 190 Kelvin. In case of hydrogen it is only 33 Kelvin. So sulfur dioxide has higher critical temperature as compared to methane, which is again higher than your dihydrogen. Higher critical temperature means easily liquefiable. You can liquefy this gas easily as compared to methane, as compared to dihydrogen. So with this we can say more amount of sulfur dioxide is absorbed on 1 gram of charcoal when compared to methane, which is again more than your dihydrogen molecule. I think with this it is clear. What is critical temperature? It is the minimum temperature for liquefaction. Higher the critical temperature, higher would be the liquefaction, higher would be the adsorption. So that depends upon the nature of the gas. Nature by means we means critical temperature or the ease with which your gas can be liquefied. That would be followed in both your physisorption and your chemisorption. We have talked about surface area. Higher the surface area, higher it is absorption. Okay, physisorption involves no activation energy since they are held by weak forces. So you don't need any kind of an activation energy for physical absorption. But in case of chemisorption, they need high activation energy. Okay? Can I rub this? So no activation energy is required, whereas in case of chemical adsorption it is required. ठीक है? You need activation energy. So it is on the basis of the activation energy. Last is your formation of layers. Physical adsorption, the molecules are held by weak forces, which are your van der Waals forces. So physical adsorption always leads to your multi-layer adsorption. Whereas in chemical adsorption you have a formation of chemical bonds. It is always unimolecular layer because bond is possible only when the molecules are close enough. They are at a distance where they can form bonds. It cannot be like you have a layer, then again you have a molecule layer, so it can form a bond with the surface. That is not possible. So in case of chemical adsorption, you have unimolecular layer. That means layer consisting of only one chain of an atom. Okay? So if I want to sum up the differences between physisorption and chemisorption, depending upon the points which I want you to remember, because it will help you to differentiate between them. First, your forces of attraction. In case of physisorption it is van der Waals forces. In case of chemisorption it is chemical bonds. Second is specificity. Physical adsorption is non-specific in nature, whereas chemical adsorption is specific. By specific we means there should be a formation of a bond. If there is no possibility of a bond formation, you won't observe chemical adsorption. Third point is, say the point at least, reversibility. Since physical adsorption is held by weak forces, so physical adsorption is reversible in nature, whereas chemical adsorption are held by strong bonds, so it is irreversible in nature. What is the fourth point? Temperature. When we are saying temperature and we are absorbing a gas, it is, we'll talk about critical temperature only when we are talking about a gas. Higher the critical temperature, higher is the liquefaction, higher would be the adsorption. What is the next point? Enthalpy. Since physical adsorption you have weak forces, enthalpy of adsorption would be low. Whereas in case of chemisorption you have strong forces, enthalpy of adsorption would be high. Or you can say it is more as compared to physical adsorption. What is the next point? Nature of adsorption. Isme we will talk about the surface area. Higher the surface area, higher would be the adsorption. And this is observed in both the cases. Physical adsorption as well as your chemical adsorption. What is the next point? Critical temperature. That we have discussed. Next point? Activation energy. Physical adsorption requires no activation energy because of the weak forces. Since you have the formation of the chemical bonds in chemisorption, so it requires high amount of activation energy. What is the last point? Multimolecular. Because van der Waals forces can operate at a larger distances also, so you have a formation of multimolecular layer in physical adsorption, whereas in case of chemisorption you have what? Unimolecular layer. I believe it is clear to everyone. I think you guys must have remembered also, right? It is mine. Okay. With this, your adsorption is over. Okay? The basic concept, what is adsorption, the mechanism, the kind of forces which are responsible for adsorption. Then we have talked about factors affecting adsorption, and the last was types of adsorption. We have covered 5 topics, and with this your adsorption is over. Now there is one more thing which is important, is like we want to study our adsorption by varying pressure. Okay, how does your adsorption changes its course of nature when you vary the pressure of the system or the pressure of the gas which is getting adsorbed on the adsorbent. Okay, so there was a person called Freundlich, who gave Freundlich adsorption isotherm. Isotherm means you are observing that at a constant temperature. Okay? So he gave this kind of a graph. Let me say this is T3, this is T2, and this is T1, where your T3 is greater than T2 is greater than T1. Sorry, it should be T1, T2 and T3. You have the amount of the gas which is like getting adsorbed, and here you are varying the pressure. Okay, and this amount of gas is getting adsorbed on adsorbent, so that is represented with this symbol M. Okay, X is the amount of adsorbate, M is the mass of the adsorbent on which your adsorption is taking place. So you observe that adsorption by varying the pressure at different temperatures. Now this is the particular nature when you are considering temperature to be a constant. If we compare different temperatures, since T3 is greater than T2 is greater than T1, you can say, if I say at this pressure, so your adsorption would be this, this and this. So what you can say, adsorption decreases with increase in temperature, because the value of X by M, but this point will give you the value of X by M and the pressure at which this is present. So as you increase the pressure, this value decreases. So you can say with increase in temperature, the amount of the gas adsorbed decreases. So this person gave an equation or an empirical relation which says x by m is equals to a constant pressure which is raised to the power 1 by n. Okay? So this is an empirical relation between, write down, this is an empirical relation between the quantity of the gas adsorbed by unit mass of adsorbent and the pressure at a particular temperature. That means we'll talk about a specific temperature or we'll study that adsorption at a one temperature. So let us take a single temperature curve. It would be like this. Okay? If we talk about a single temperature, that means you're observing that reaction at a constant temperature. The temperature is not varying during the course of the adsorption. Now let us first see how does your graph behaves when you change the pressure. Initially, when there is no adsorption, you have a highly active adsorbent and your gases. They are not interacting with each other, they are present separately. You allow your gas molecules to get adsorbed on the surface. Initially, the residual forces would be very high. Okay? Initially, the residual forces would be very high. So what you can see, when the pressure is low and the reaction is just like happening, adsorption is taking place, there is almost a linear relationship between pressure and x by m. So you can say at low pressure, your x by m is directly proportional to pressure, or you can say it is raised to the power 1. This is clear? We are talking about low pressure region. As the pressure increases, or let me say we talk about very high pressure. High pressure matlab in this region, you can say it becomes almost parallel to your pressure axis, right? That means adsorption is constant. There is no more increase in the adsorption. So you can say your x by m, this value is remaining constant. It is not varying with the pressure or it is not varying with the increase in the pressure. So it is directly proportional to the pressure, but that pressure is raised to the power 0. That means its concentration is not affecting adsorption. Raised to the power means it is there, your gas is there, is present at a high pressure, but since all the residual forces are balanced, all the surface valencies are satisfied, there is no space for adsorption, so it becomes constant, or you can say surface is completely saturated. Okay? Surface is completely saturated. Now whenever you remove proportionality sign, you get what? A constant. So if I remove my proportionality sign, I'll get a constant. Let me say I'll write it with this word constant into p raised to the power 1. Similarly, you will have this constant p raised to the power 0. Now in between these two pressure, let me say this is lower pressure region, this is your higher pressure region, this is this pressure. Okay? Let me say this is low, this is high pressure region, a dotted line. In this region, adsorption increases as the pressure is increasing, and that is expressed by this equation. You can call an intermediate temperature, pressure. Intermediate pressure, your x by m is directly proportional to the pressure raised to the power n, where n is a constant related to the kind of a gas. Here also, when you remove the proportionality sign, you get a constant into pressure raised to the power 1 by n. So when you combine these three equations, you get this expression. And here the constant is expressed by k. So you write down x means the mass of gas adsorbed, x means the mass of gas adsorbed, m denotes the mass of adsorbent taken, k and n are the constant, and P is the varying pressure. Okay? During the adsorption you are varying what quantity? You are varying your pressure. I'm clear till here? Now I want to check the validity of this expression. This person said okay, this is how adsorption takes place, and at lower pressure there is almost a linear relation. With increase in pressure adsorption also increases, but at a very high pressure it becomes saturated. That is, there is no increase in the adsorption. Or you can say his theory, whatever the theory is saying that x by m is directly proportional to pressure, it fails, actually fails at a higher pressure. I want to validate this expression. So what I'll do, I'll take a log of this value. When you take a log, this becomes log of x by m is equals to log of k plus, since this is in multiplication, we will have a plus sign, log of p power comes as this. So this expression is similar to y is equals to mx plus c, an equation of a straight line. Y is this quantity, x is this quantity, m which is your slope, and c which is your intercept. This is, I believe, known to everyone. Okay, so what you will do to check the validity, we will take or will plot log of x by m on the y-axis and log of pressure on the x-axis, and if we obtain a straight line, that means this isotherm is followed or this isotherm is valid. If you are not getting a straight line, that means this isotherm is not followed or it is not valid. In which when you extrapolate this line, you will get what? Intercept. This intercept is equals to log of k. And when you take the slope, that slope would be equals to 1 by m. Sorry, 1 by n. Okay? Clear to everyone? Now you understand what is friendly adsorption isotherm. This is the person who actually gave an empirical relation which talked about the amount of the gas adsorbed on the surface of adsorption by varying pressure at constant temperature. When you vary the temperature, your pressure, your amount also changes. It decreases with increase in it decreases with increase in temperature. Okay? Clear? Okay. Yes. Okay. From the beginning. Now let us just revise it again, okay, so that you can understand it more. Friendlich is the person who gave an empirical relation between the amount of the gas adsorbed on the surface of adsorption isotherm. Okay, so if we plot x by m, where x is the amount of gas adsorbed on the certain mass of an adsorbent versus pressure, you will get this kind of a curve. Okay, now we'll see different parts of the curve by varying pressure. First, let us say we are observing a very low pressure. That means pressure is very low. Initially, when there is no adsorption, you have your adsorbent or surface separately, you have your gas separately, there is no adsorption. Surface energy or the residual forces of your surface would be very high. They are completely vacant. Okay? There is no molecule at the surface. So when you add your gas to that surface, adsorption increases in a manner that this is almost linear. Initially, if I talked up to this region, at a low pressure region, the relation between x by m is almost linear with respect to pressure. By power 1 means the way pressure increases, adsorption increases. Second, we have talked about high pressure region. But you can see at high pressure region, this curve has almost become parallel to your y-axis. That means you are increasing the pressure, but there is no change in the amount of gas adsorbed. There is no change in the amount of gas adsorbed. So what you can say, at high pressure we have x by m is also proportional to gas, but its constant or its presence is not affecting the adsorption, because the adsorption is complete, or you have reached a saturation level. You have reached a saturation level, or you can say the surface is saturated completely. Your surface is saturated completely. Now if I remove the proportionality sign, I'll get from first expression x by m is equals to a constant into p raised to the power 1. From the second expression I'll get x by m is equals to a constant into p raised to the power 0. In between these two pressure, which is like this area, which is not the dotted region, you can say adsorption increases with increase in pressure, and you will have this relation which says x by m is directly proportional to p raised to the power 1 by n. Now this raised to the power 1 by m has been observed experimentally. That's why you have denoted this factor in the denominator. Now when you combine these three equations, you will get x by m is equals to a constant, where you take this constant as k p raised to the power 1 by n. Okay, when n is 0, that means no gas. This becomes, that is, pressure is not affecting the adsorption. When it is 1, that means linear relationship. 1 by n means adsorption increases with increase in pressure. Okay? So you get this expression. This is known as, this is the empirical relation given by Fenlich, which says how does your adsorption of a gas varies with increase in pressure. Now to test this equation, what we'll do, we'll take the log of this equation. By taking log, we'll have this log of x by m. Can you just ask this person to stop this? Log of x by m, log of k plus 1 by n. Since it is in the power, तो ये आगे आएगा log of p. So this is equals to your straight line equation, which is y is equals to mx plus c. Y is log of x by m, c is this constant, m is your slope, and x is your log p. So what you will do, you will plot log of p by taking it on the x-axis. You will take log of x by m on the y-axis. If you get a straight line, that means this isotherm is valid. If you don't get a straight line, that means this isotherm is not valid. The slope of the isotherm gives the value of 1 by n, and the intercept gives you the value of log k. Clear to everyone? Okay. Till now we have talked about the adsorption of gaseous molecule. The adsorption is also possible in solutions. It is similar to the way we have talked about gaseous species, but in case of solution, your solution will have a solute molecules. Okay, for example, let me consider an example. Acetic acid, I believe you know what is acetic acid. What is acetic acid? CH3COOH. So what you will do, you will take a solution of acetic acid. Let me say acetic acid is dissolved in water. Okay? You take a solution of acetic acid. Solution means you have solute plus solvent. We are saying acetic acid solution means your solute is which molecule? Acetic acid. Solvent is which molecule? Your water. Okay? So you have a solution of acetic acid in water. Now to this solution, what we add? Activated charcoal. Activated charcoal. What happens when you shake the solution, allow it to rest for some time, let me say 3 or 4 hours, the amount of acetic acid in the solution decreases. Why it decreases? Because that acetic acid get absorbed on the surface of charcoal. So adsorption is also possible in solution. So write down adsorption from solution. Adsorption from solution. ठीक है? So adsorption or solid surface absorb solute molecules from the solution. For example, when you take a solution of acetic acid get absorbed on the surface of the charcoal. Another example is like you take a dye solution, any dye, let me say methylene blue, you are taking a methylene blue. To that solution also you add charcoal. You know what is filtrate? Left out part. So when you shake your charcoal, what happens after some time? Let me say you have a solution of methylene blue. After some times that solution become colorless. Good. Why it becomes colorless? Because the dye molecules get adsorbed on the charcoal. So what we are observing here, that adsorption is also possible in solution. What is getting adsorbed? It's your solute molecules. Okay. So here also we can say the extent of adsorption. I want you to note down certain points. The extent of adsorption decreases with increase in temperature. Extent of adsorption decreases with increase in temperature. The extent of adsorption increases with increase in concentration. It increases with increase in concentration. Here also the adsorption increases if you increase the surface area of your charcoal or the kind of adsorbent you are taking. Extent of adsorption increases with the surface area of the solid molecule or the adsorbent molecule. And this adsorption also depends upon the nature of the adsorbate molecule. Okay. Now to explain this, you can use the same expression which you have used to explain your friendless adsorption isotherm. In doing so, what we'll do just is that we'll replace our pressure with concentration. Okay? Since you are talking about solutions are always represented with the help of concentration, and here your concentration is varying instead of pressure, so the equation becomes this. Same cheese. Adsorption increases with increase in concentration. Initially when there is no adsorption, there would be a direct relation initially. At higher concentration, when all the surface sites are occupied by the solute molecules, it becomes completely saturated. So it becomes independent of concentration. In between this lower concentration range and a higher concentration range, you have adsorption. It will increase till there is saturation. To validate that, what we'll do? Log. Okay. So here also we'll plot two values, log of x by m. Instead of pressure, you will take concentration. You will get a straight line. If you get a straight line, that means this equation is valid. If you don't get a straight line, that means the equation is not valid. Intercept gives you the value of log k. Slope gives you the value of 1 by n. Very good. So with this, your adsorption is over. Your adsorption is complete. The first topic which we have taken up today is complete. We have talked about so much about adsorption. Let us discuss few examples from our day-to-day life. Okay. Adsorption is like something like we want certain reactions in vacuum so that there is no interference of the impurities. Okay. That vacuum is created with the help of your adsorbent or adsorption. All the impurities get adsorbed on the surface of your adsorbent, and that place where you want your reaction to study becomes completely avoid, or it becomes independent of the impurities. Okay? So it is used, you can write down, it is used to create high vacuum. It is used to create high vacuum. Generally you use activated charcoal. Generally we use activated charcoal to remove trace amount of gas or air present in the system. Second application is gas mask. Okay, I know you guys are familiar with this gas mask. Okay, gas mask is also, it may consist charcoal, they are made of charcoal. So whenever the air particles flow through that gas mask, the what you inhale would be independent of any kind of an impurities. Okay, or the poisonous gases. The major application of these gas mask is the coal mines. But these days you guys must have seen that police traffic people are wearing gas masks because the pollution in Delhi is very high. So the stage is, I think, very near, then we would be supposed to wear the gas mask so that you can avoid pollution. Okay. Next is like to control the humidity. When you want to control the humidity, that means you want to control the amount of air, the amount of liquid or the water molecule suspended in the air. So we'll use those molecules which adsorbed gas molecules. You are right. We'll use silica molecules. So on silica, your water molecules get adsorbed at the surface. Okay. Or koi example, any example you guys can suggest to me? You guys have seen sugar at your houses? Right? Pure crystal, clean. Have you seen how sugar is being made? You know sugar cane is used for the synthesis of sugar. You take the juice. I think you guys have seen at least sugar juice to sabne dekha hoga. That is colored. When you are heating that color solution, the color will increase. But what you are getting is a pure crystalline form which does not have any kind of impurity. So to remove that color, you add animal charcoal. You allow that raw sugar syrup to pass through that charcoal, and in doing so, excuse me, can you please that ask person? In doing so, what we see, the colored impurities which are there in the sugar solution, they get absorbed out of the charcoal, and we get a clear syrup of sugar which is responsible for a finely crystalline clear sugar molecules which are using at your houses. Any other example you want to suggest? Yes, smoke precipitator. Smoke precipitator, like because of the industrialization, you have a lot of industries setting up around us. So what one of the norms of the industries is that the smoke which is coming out of those industries should be in a pure state. Pure doesn't mean ki it is pure. It should have a less amount of impurities. So it is allowed to pass through a chamber where that dust particles or the smoke particles or the carbon particles or any other impurity, they get precipitated in that chimney. So the smoke which is coming out of the industry would be having less amount of gases which are harmful for your environment. Any other example from your, let me say, when you purification of ores, froth flotation sabne suna hai? It is for the concentration of the sulfide ore. What we do, we take finely powdered ore of a sulfur, we take it into a very big container in which you add small amount of oil. Sulfide ores get attached to that oil molecules. So also your sulfur molecules are getting adsorbed on the surface of oil. See, this is also an application of your adsorption. So I believe adsorption is clear to everyone. So to sum up what we have talked today in adsorption, we have talked about adsorption, we have talked about adsorbate and adsorbent, we have talked about the mechanism, we have talked about the forces which are responsible for adsorption, then what are the factors which are affecting the adsorption, we have talked about types of adsorption, and an important empirical relation which is your Fenwick isotherm, and also how your adsorption is there in the solutions. With this, your adsorption is over. Now the next topic which we'll do is your catalysis. Okay, this is the second chapter of this unit. which is your surface chemistry, is catalysis. I think you people must have heard this word catalysis. थोड़ा बहुत idea सबको होगा, right? Okay. First, the basic concept. What is a catalyst? A catalyst is a substance which increases the rate of a reaction without being consumed during the course of the reaction. ठीक है? So it is a substance which increases the rate of reaction without getting consumed, or it remains as it is, consumed during the course of the reaction. This is your catalyst. The process of this is known as catalysis. Okay, when these two takes place simultaneously, you have phenomena which is known as catalysis. Okay. For example, let me say you have a decomposition of potassium chlorate. Okay, it decomposes at a very high temperature to give you potassium chloride and oxygen. I'm not doing the valency part. I just want to focus more on the concept. This decomposition is valid at a very high temperature. High temperature means something of 600 or 700 Kelvin. And that means it is a very high temperature. But when you add MnO to this system, this temperature decreases down to some 300 to 400. I'm just taking approximate values. These are not the exact values. Okay. So what this MnO2 is doing, it has increased the rate of the reaction. That means it has decreased the temperature at which the reaction can take place. Also it is remaining unchanged. You can have your MnO2 back from the system. So it is acting as a catalyst in the decomposition of the potassium chlorate. Okay. How does a catalyst work? It decreases the activation energy. Now if I want to study the reaction profile of a reaction, you take reaction coordinate on the x-axis and you take your energy on the y-axis. If you have reactants here, okay, and you have your product here. In converting a reactant to the product, it passes through high energy barrier. Okay? The difference between these two is the amount of energy heat release. This is the activation barrier or the activation energy required. This is the activation energy required to cause the reaction. So what does the catalyst does? It decreases the activation energy. Initially जो इतना था, now it has decreased down to this value. So what does the catalyst do? It decreases the activation energy, right? How does it do? It provides alternate pathway. Alternate pathway means alternate route for the reaction. The K equilibrium of the reaction remains same. That means the rate of the forward reaction and the rate of the backward reaction are enhanced to the same extent. Also, the heat change during the reaction remains same. So, a catalyst is a substance which increases the rate of a reaction by decreasing the activation energy, which leads to an alternated pathway through which a reactant can be converted to product, and in doing so the K equilibrium or the equilibrium constant of a reaction remains same. That means rate of the forward reaction as well as the rate of the backward reaction, they are enhanced to same extent. Also the enthalpy of the reaction remains same. So you have understood this word catalyst. Okay, what is your catalyst? Clear to everyone? Okay. Next is your types of catalyst. You have two types of catalyst. First is your homogeneous catalyst, another is your heterogeneous catalyst. Okay. By homogeneous we means your reactant and catalyst. Homogeneous means reactant and catalyst both are in same phase. They are in same phase. But when we say heterogeneous, your reactant and catalyst are in different phase. They are in different phase. Okay. For example, we'll just consider a single example. Oxidation of sulfur dioxide, which is in gaseous state, when combines with oxygen in gaseous state in presence of nitrous oxide, which is also in gaseous state, you get sulfur trioxide. Reactants are in gaseous state as well as your catalyst is in gaseous state. Now if you want to study the same reaction, SO2 in gaseous state is oxidized with the help of platinum in the solid state. You will get your sulfur trioxide. I am not doing with the balancing part, that you guys can do on your own. Okay, so same reactant. Here the catalyst is in the same state. Here your catalyst is in the different state. Similarly, you have more examples that you can read from your book also. I'll just do it. First is your another example in case of homogeneous catalysis is hydrolysis of methyl acetate. Hydrolysis of methyl acetate means it undergoes hydrolysis. What is methyl acetate? CH3COO. This is methyl acetate. This is in liquid state. Hydrolysis means you are adding water in liquid state. In the presence of HCl in liquid state, you have acetic acid and methanol. Okay. One more example is hydrolysis of sugar. When your sugar is hydrolyzed, liquid state is hydrolyzed in presence of sulfuric acid, you get glucose molecule and fructose molecule. You get glucose and fructose. These are the examples from which you can say that whether this reaction is homogeneous or heterogeneous. Similarly, when you talk about heterogeneous reaction, by just looking at the state or physical nature of your reactants and your catalyst, you can say the reaction is heterogeneous in nature. Okay, you can have one more few examples in your heterogeneous also. Synthesis of ammonia. ठीक है, Haber process. You take nitrogen, you take hydrogen, you allow it to pass, allow the reaction to happen at a particular temperature and a pressure in the presence of finely divided iron. ठीक है, you get your ammonia. Similarly, you have hydrogenation of oil, vegetable oil, which leads to the formation of vegetable ghee. ठीक है, you use that would be in solid state or a finely divided state. So when the states are different, or when the phases are different, that catalysis is known as heterogeneous. When the phases are same, that catalysis is known as homogeneous. This is clear what are heterogeneous, homogeneous. Next is the mechanism or the theory of catalysis. There are three theories which are developed during the course of this catalyst. One theory which says, which is also known as old theory of catalysis, which says that during your adsorption, reactant molecules get adsorbed at the surface of catalyst. As the concentration of the reactant molecule increases, adsorption or catalysis increases, and during that reaction, heat is released. That heat would be used for the increase in the rate of catalysis. ठीक है? What does your old theory says? Reactant molecules are adsorbed at the surface of catalyst. When the concentration of the reactant molecule increases, the rate of catalysis increases. During this adsorption, heat is released. That heat would be used for further enhancing the rate of the reaction. This is your old theory. Okay. Second theory, which is also known by your intermediate theory, which says that during the course of the reaction, like you have A and B, they are getting converted to your products without any catalyst. It would have a very high energy barrier, or the activation energy is very high for this reaction. But when you study the same reaction in the presence of catalyst, let the catalyst is C, you will get the formation of product, but that would be in a lesser time. Also the activation energy is decreased. Okay, so in doing so, what happens? Let me say this is the surface of catalyst. Your reactant molecules get adsorbed on the surface of the catalyst. At the surface of the catalyst, they will form an intermediate. So it is due to the formation of this intermediate. This theory is known as intermediate catalysis theory or intermediate theory. They forms an intermediate. After this, you will have your catalyst back and your molecule. So you have a formation of an intermediate, or you can say A plus B, AB, and it is getting converted to product. This is your intermediate. Okay, that is why it is known as intermediate theory. Now what does the adsorption theory for heterogeneous catalysis, which is important for you, which is basically a combination of these two theories, consists of several steps or just 5 steps. First is diffusion. So write down the steps involved in theory of, which is important theory, or you can say the modern theory, which is followed these days. Modern theory of adsorption. Of reactants. It consists of 5 steps. First is diffusion. Second is adsorption. Third is a chemical reaction. Fourth is desorption. And the fifth is again diffusion. These are the 5 steps which are there in this theory of adsorption. Okay, now what does these steps include? When you are saying diffusion initially, your reactant molecules are diffused towards the surface of catalyst. Okay, the first step says diffusion of the reactant molecules towards the surface of the catalyst. Second step says adsorption. Adsorption of the reactant molecules at the surface of catalyst. Okay, adsorption of the surface molecules at the surface of catalyst. Once the adsorption is there, it will lead to a chemical reaction between the reactant molecules at the surface of catalyst. Once that reaction is complete, you have your product, but that product would still be at this or near the surface of the catalyst. So that molecule should be desorbed. If desorption is not there, the place where your reactant molecules are there, it will remain always occupied. That means that place is blocked. Catalyst is getting consumed. We don't want catalyst to get consumed, or catalyst has the important property that it does not get consumed during the course of a reaction. So that product molecule should go away from the surface of the catalyst. That process is known as your desorption. Diffusion is like further going away of the product molecule from the surface of the catalyst, so that that same space can again become available for further reaction. If I want to show this diagrammatically, let me say this is your catalyst and your reactant molecules. Okay? This is the diffusion state when you are making your reactant molecules going close to the catalyst surface. Catalyst surface has free valencies or unsatisfied valencies. Then it will lead to adsorption. Okay? Adsorption will lead to this. The molecules are getting adsorbed at the surface of catalyst. Then what you have? Chemical reaction. That means formation of intermediate. You will have a product once that molecules from the surface are removed from the surface of catalyst. Till it is there at the surface, you will call it as an intermediate. During the formation of intermediate, you will have a formation of product molecule. Okay? Then you have desorption. And plus your product molecule. And after this, you will have your diffusion. Okay? This is intermediate formation. So you can see from this diagram also that at the end you have your catalyst back, okay, which can again be reused for further reaction. Okay, steps are clear. Theory of catalysis or heterogeneous catalysis consists of 5 steps: diffusion, adsorption, chemical reaction, desorption and diffusion. First diffusion, you are talking about reactant molecules. Last diffusion, talking about the product molecule. Both the diffusion means reactant should come close to the surface of catalyst, product should go away from the surface of catalyst. Adsorption means reactant molecule should get adsorbed at the surface of catalyst. Desorption means product molecule should get removed from the surface of catalyst. Chemical reaction means the catalyst will allow the reactant molecules which are adsorbed over the surface of catalyst to interact with each other. In doing so, they will form an intermediate which is responsible for increase in the rate of a reaction. Once the intermediate form, you will have a formation of the product and again you will have diffusion. So these are the 5 basic steps or the important steps in which your catalysis work. Is it clear to everyone? Okay. One more thing which is like important is we are saying that reactant molecule should get adsorbed at the surface. In doing so, the reactant molecule should get adsorbed, but that adsorption should not be that strong that it becomes immobilized. You cannot move or take away that reactant molecule away from the surface. That propose or that act as a problem during the catalysis. If this happens, then that catalyst won't work efficiently, or that reactant molecule will act as a inhibitor. Okay? It will act as an inhibitor or a poison because it will decrease the rate of the catalyst. Because initially, let me say, if 10 sites were available for the reaction and one site has been occupied, the number of site has decreased. The rate which was initially like say 10 times increase, where it won't be 10 times, it would be less than that amount. So reactant should get adsorbed, but that extent of adsorption should not be very strong. They should be able to mobilize the reactant molecules. So with this, you can say there are 2 important features or properties of a solid catalyst. Write down. The 2 important properties of the solid catalyst is, first is your activity. First property is activity. And second is selectivity. By activity we means the extent to which the rate of the reaction has been increased. By activity we means the rate of the reaction, that is the extent of the reaction to which the speed of the reaction has been increased. We have discussed right now that reactant molecules should get adsorbed to an extent that they do not become mobilized or immobilized on the surface. They should not become immobilized on the surface. They should be able to react and get diffused away from the surface. That is activity of the catalyst. Activity of the catalyst should be maintained. If it is not maintained, that means you are deactivating the catalyst. or that reactant molecule is acting as an inhibitor or a poison. Okay. By selectivity we means that a catalyst should be able to catalyze a particular reaction. For this I want you to note down these reaction. You have carbon monoxide in gaseous state, hydrogen in gaseous state. Here you have 3 molecules, 2 molecules of hydrogen, carbon monoxide again, 1 molecule of hydrogen. Same reactant species, ठीक है? You have formation of methane, you have formation of formaldehyde, sorry, you have formation of methanol, and you have formation of methyl. ठीक है? The products are different. Reactants are same, but the products are different. That means it depends upon the kind of catalyst with which are using. Now the methane has been generated in the presence of nickel. Whenever you use nickel, these reactants will always give you methane. That means these reactants are selective to nickel catalyst. It is the important property of a nickel catalyst which leads to the formation of methane. When you study the same reactants or allow the same reactants to react in presence of this Cr2O3, you have a formation of methanol, and this in presence of solid copper. These are heterogeneous catalysts, okay? They would be in solid state, finely divided, powdered form. Methane, and you will have byproduct also, water. We don't have anything, and yes. Okay? So by selectivity we means ability to direct a reaction in a desired direction. By selectivity we means ability to direct a reaction in a desired direction. Okay, there's one more kind of a catalyst which are your shape selective catalyst. Shape selective means we are interested in the shape of the catalyst as well as the reactant. So you can say the reactions which depends upon the pore size of the catalyst, reactions which depends upon the pore size of the catalyst and the nature and the size of the reactant molecules, and the nature and the size of the reactant molecules comes under your shape selective catalysis. They comes under your shape selective catalysis. The most important or the common example under shape selective catalysts are your zeolites. Okay? They are your zeolites which are like widely used. ZSM5 has a major application in chemical industries. They are basically aluminosilicates. They are aluminosilicates which means you have a 3D network of silicon molecules or silicon oxides in which some of the silicon molecules are replaced by aluminum atoms, which leads to a network of this aluminum oxygen sulfide. Okay? And you get honeycomb like of a structure. So these cavities act as pores. Okay? The presence of pores, these cavities, because of the special arrangement of these molecules, you get pores. It is because of the presence of these cavities the reaction becomes shape selective. Reactants which are easily to pass through this size are allowed, or that reaction will happen, otherwise that won't happen. So the most important is your ZSM5, which means zeolite sieve. Zeolite sieve of microporosity. ZSM means zeolite sieve of microporosity 5. Okay, this is the size of the pore size of this particular zeolite. So it is used in petrochemical industry, in which what they do, they convert a mixture of hydrocarbons into directly into gasoline. So write down what they do, they convert alcohols directly into gasoline by dehydrating them to give a mixture of hydrocarbon, by dehydrating them to give a mixture of hydrocarbons. So this is your shape selective catalysis. With this, catalyst is over, but one topic in catalysis is still left, which is your enzyme catalysis. Enzymes are very important to us, right? Because majority of the reaction which are happening in our body are catalyzed with enzyme. If that enzyme is absent, that particular reaction won't happen. Okay, for a single cell to function, you need some 3000 enzymes so that that cell can function properly. So enzymes are basically, or you can say, all the biological processes are catalyzed by special kind of catalysts which are known as enzymes. Biological processes are catalyzed by special kind of catalyst which are known as enzymes. So they are also known as biological catalyst. They are also known as biological catalyst. Enzymes are generally protein. Enzymes are generally proteins with high molecular mass ranging from 15,000 grams per mole to 1 lakh grams per mole. That means they have high molecular mass. Proteins have high molecular mass. Sometimes enzymes are associated with non-protein part, which is known as cofactor. They are associated with non-protein part, which are known as cofactor, which are required for the activity of the enzymes. Okay, which are required for the activity of the enzymes. For example, let us do some examples, or so that you will be able to understand what are enzymes. First example is your conversion of cane sugar to, what you will get? Exactly, you get glucose and fructose. I'm not giving you the molecular formula, that you can have on your own. Okay, so this conversion takes place in the presence of invertase. So this particular reaction is catalyzed in the presence of invertase. Second reaction, you just write down the conversion of glucose to ethyl alcohol. This is happening in the presence of zymase. Third reaction, you can have the conversion of starch to, किस में जाएगा starch to maltose. So this will happen in the presence of diastase. Okay, fourth reaction, you will have the conversion of maltose to glucose. You will have which enzyme? Maltase. Fifth, the conversion of urea to ammonia. ठीक है? This happens in the presence of urease. Okay? Proteins, they get converted to peptides, or they get directly converted to amino acids. When they are getting converted to peptides, this is happening in the presence of pepsin in the stomach. When they are converting directly into amino acid, this is due to the pancreatic enzyme. Which enzyme is that? Trypsin, which directly converts your protein into amino acids. So these are particular reaction and जो आप घर में daily use करते हो, conversion of milk into curd using lactobacilli. ठीक है? So these are the enzymes which are responsible for converting your reactant into product, and they happen at a very fast pace. Like you can have a curd in 2-3 hours if you have a particular temperature. In winters you have difficulty in setting curd because of the low temperature, but if we can increase the temperature somehow, it will happen in 2-3 hours. So these reactions, or you can say you can have the same products or same reactant, but the products would be different depending on the kind of the enzyme we are using. So they are selective in nature. You cannot expect urease is converting urea. Urea is an amide. Okay, so you can expect कि urea किसी और amide पे भी act करेगा. That is not going to happen. Urease is selective to urea only. It won't convert any other amide into ammonia. Okay. So these are some of the enzyme catalyzed reaction which we observe. They are there in our system or things which are present around us. So just write down. I want you to we first discuss what are the characteristics or the properties of the enzymes. Then we'll discuss the mechanism of the enzyme catalyzed reaction. So under properties, the first property is your efficiency. First property is your efficiency. By efficiency we means that enzyme is able to increase the speed of a reaction to a factor of 10 raised to the power 20 times. A single enzyme can convert billion of reactant molecules into product in just few seconds. That is the efficiency. Efficiency means how much we can efficiently convert our work into some useful thing. For example, I am teaching you. If my efficiency is low, I won't be able to complete the topic which we have taken today. But if my efficiency is high, we'll be able to complete that, provided you people have acquired that knowledge. If you have not acquired, that means the efficiency is 0. Clear? The rate at which we can increase the reaction, that comes under efficiency. Second point is specificity. As I've already said that urea is an enzyme which acts on, urease is an enzyme which acts on urea. Urea is an amide which converts urea into your ammonia. But this same enzyme cannot convert any other amide into your some kind of a product or ammonia. So it is the selectivity of the enzyme. An enzyme would be able to catalyze only a particular reaction but not the all reactions. So you understood what is specificity? Third important property is optimal temperature. The enzyme activity is high at optimal temperature, or you can say the moment you approach optimal temperature or optimum temperature लिखो आप इसे, optimum temperature, the activity of the enzyme increases. Below this optimum temperature and after this optimum temperature, the enzyme activity is less as compared to the one which is present at optimum temperature. For our body temperature, which is like 298 Kelvin to 310 Kelvin, or which is the room temperature, okay, 298 is the room temperature, 25 degree to some 37 degree, which is our maximum temperature allowed. So this is the optimum range where the enzyme can catalyze your reactions efficiently. Okay? The third factor or the property of a catalyst is your optimal temperature. Next is your optimum pH. Enzyme catalytic activity would be high at optimum pH, which is of the order of some 5 to 7 pH value. ठीक है? अगर इतना pH होगा, if this pH is there, you will have high activity. If it is not there, if it is less than or more than this, you will have less activity of the enzyme. ठीक है? There is one more way where we can increase the activity of the enzyme by adding activators or coenzyme. You can increase the activity of the enzyme by adding activators and coenzymes. They are used to increase or enhance the activity of the enzymes. Okay, they are used to increase or enhance the activity of the enzymes. Coenzymes, as we have already discussed, they are non-protein parts which are necessary for the activity of the enzyme. Activators are generally some of the metal ions. Metal ions like you need uh, just write down sodium ions, manganese ions, cobalt ion, Mn2 plus, cobalt 2 plus, copper ions. They are required for increasing the activity of the enzymes. So these are the 5 characteristics or the 5 properties of your enzymes. Efficiency, speed, extent of speed, कितना बढ़ा दिया. The efficiency amount of speed reaction has increased. Specificity, it will catalyze a particular reaction, not all the reactions. Optimum temperature would be the high enzymatic activity. Below and above the optimum temperature, you have low enzymatic activity. At optimum pH, high enzymatic activity. Some pH other than the optimum pH, you will have low enzymatic activity. You can increase the enzymatic activity by adding activator and a coenzyme. Coenzyme is a non-protein part which is associated with the protein which is acting as an enzyme. It is necessary for the enzyme to act as a or work properly. You can increase the enzyme activity by adding metal ions. Certain metal ions are, we know na, certain metal ions or we need certain minerals so that our body can function properly. Okay, we say that like hemoglobin, it needs iron. Iron should be there so that it can work properly. If that amount decreases, you become anemic. Okay, so these are the certain properties of your enzymes. Next topic is your enzyme mechanism. Lock and key mechanism follow करता है. ठीक है, what do you know what is lock? You know a key. A lock will always have a particular key. You cannot open that lock with any key. It will have a particular key. Similarly, enzyme is selective to the kind of a reactant molecules. Now, what do the enzymes or these protein molecules have in them? Protein molecules have some shape or some pockets or some cavities in them where your enzyme will come and sit. In doing so, when it is sitting, it will interact with the active group at these pockets, or you can say your reactant species or your surface is acting as what? Or you can say this is your substrate, your lock. This is your reactant species. Enzyme is acting as a key. It is getting into your lock so that you can have a formation of an enzyme and substrate complex. If it will have some active group on it, which can interact with the groups on the reactant surface, then you will have your product. If it is not there, or you can say enzyme is not the correct enzyme, you won't have any enzymatic activity. If you want to do this, the steps which are there in the enzymatic activity are, you have an enzyme, you have substrate, it leads to the formation of enzyme substrate complex, and this will decompose to give you enzyme back and your product. Let me say your enzyme looks like this. Okay? Your surface should have a cavity opposite to this. Okay? So it will lock with this substrate species to form your enzyme substrate complex like this. Okay? This is your enzyme substrate complex. When it decomposes, or you will have your enzyme back and your some product molecule. Okay? So this is also known as lock and key mechanism. Okay? Now this mechanism consists of 2 steps. First step is this, formation of enzyme substrate complex. This is your first step. Mechanism of catalysis enzyme means it consists of 2 steps. It's a 2-step mechanism. First step means formation of a complex between enzyme and substrate, where substrate is your reactant molecules. Second step is decomposition of enzyme substrate complex. decomposition of enzyme substrate complex to give you enzyme back and your product molecule. Okay. So what you can see that your reactant molecules have certain cavities in which you have certain functional groups, which can be your acetic acid, which can be your amide, which can be your you can have what other group. Proteins are made up of what? Amino acids. Okay, so you can have thiol groups, you can have SH group, you can have OH group. These are the active groups which are present there, and if it is there in the enzyme, then only that complex would be there. There should be interaction between these active groups. If these are not activated, your enzyme substrate complex is not formed or enzyme won't function properly. So mechanism is clear. You have active sites at the surface of the substrate. Enzyme having the correct molecule which can interact with the active site is going to get entered into the substrate enzyme substrate complex, so that it can lead to the formation of the product. If the active sites are not matching up properly, you won't have any formation of the enzyme substrate complex. So with this, your catalysis is over. So what we have done in catalysis? What is catalysis? Catalyst, and that process is known as catalysis. Catalyst is what? Which enhances the rate of the reaction. Okay. Then what we have talked about? Type of catalysis. Homogeneous catalysis and heterogeneous catalysis. Then we have talked about the mechanism of catalysis, which is generally derived from two older mechanism, which is your old mechanism and intermediate mechanism, which can combine to give you a new mechanism which is followed these days, which consists of your 5 steps: diffusion, adsorption, chemical reaction, desorption and diffusion. After that, we have studied important kind of enzymes which are our biological enzymes. How they are selective and efficient. Important thing about biological enzymes are they are highly specific in nature. They won't catalyze any other reaction like ऐसे ही कुछ भी करवा लिया. That is not going to happen in the case of your biological enzymes. They are highly selective in nature. They will work only at an optimum pH and an optimum. You can increase their activity by adding activators and coenzymes. What is the mechanism? It is a lock and key mechanism. This is clear to everyone? Okay, with this, the second topic of your surface chemistry is over, and we are left with the third topic, which is your colloids. Okay, so now we'll start with colloids. Okay, before getting into what are colloids, let us consider we have a solution of sugar in water. You have a solution of sugar in water, and you have a solution having mud in water. ठीक है, दो solutions हैं आपके पास. One is sugar in water, another one is mud in water. Sugar is completely soluble in water, so will you get a clear solution. So those solutions are also known as true solutions. Okay, they are also known as true solutions. But when you add mud into water, as long as you keep the stirring process on, your mud particles will remain suspended in your water system. The moment you stop your stirring, what happens? The mud particles start settling down. That stirring portion, the solution which we are getting during that stirring, is known as suspension. That is known as suspension. So once your settling up of the mud particles is over, let me say you have some this kind. You get your mud particles at the base, and some of the particles are suspended in the solution. You guys must have done this. मिट्टी ली, पानी में डाला, घोला, and allow it to rest. You will get some colored solution. That colored solution is your colloidal solution. Okay, that colored solution is your colloidal solution. So colloidal solution is actually between your true solution and your suspension. They lie between your true solution and suspension. You understood the difference? How you get colloidal solution? Particles, when they remain in suspended form in the medium or the solvent, then that is known as colloidal solution. If that particles get suspended or settled or they get precipitated, then that won't remain a colloidal solution. That will become a precipitate and you will have a filtrate, clear filtrate. Okay, so you can have a first difference on the basis of particle size, which says when the particle size is less than 1 nanometer. Okay, when the particle size, first differentiation is on the basis of particle size is less than 1 nanometer, you have two solution. When the particle size is greater than 1000 nanometer, you have suspensions. When the particle size is between 1 nanometer to 1000 nanometer, you have your colloidal solutions. Okay, you have your colloidal solutions. Clear to everyone? This difference is on the basis of the particle size. Okay, whenever we say solution, the first thing which comes into your mind is solute and solvent. Okay, you have solute and solvent. The combination of two gives you solution. It can be true, it can be colloidal, it can be suspended. On the size of the solute particle, on the basis of the size of the solute particle, you assign your solution to be either true, colloidal, or clear, or suspension. But when you're talking about a colloidal solution, you cannot use this word solute or solvent. You can use, but it is preferred to use dispersed medium, and solvent के केस में we call it dispersed phase. This is just कि they are nothing but the same thing, but when you're talking about a colloidal solution, instead of using solute or solvent, we prefer to use dispersed phase and dispersed medium. Dispersed phase are the particles or the molecules which are suspended in the dispersed medium. Sorry, dispersed. I think I have done. Sorry, solute is the dispersed medium and this is dispersed phase. Okay, solute is phase and this is dispersed medium. I think I'm saturated now. And the combination of this gives you colloidal dispersion or colloidal solution. Okay, and the combination of these two gives you colloidal dispersion and colloidal solution. One more thing is that your true solution are homogeneous in nature, whereas your colloidal solution are heterogeneous in nature. Heterogeneous means these two things, your dispersed phase and dispersed medium, can be in different state. Okay, they are in different state. You are able to distinguish between your dispersed medium and your dispersed phase. Heterogeneous in nature. This is heterogeneous in nature. Okay, next is there are certain topics, we'll do it one by one. First is the classification of colloidal solution. The first topic which we are going to do in colloids is classification of colloidal solution. Now there are three kinds of classification which are used in colloidal solution. First is on the basis of physical state. First on the basis of physical state. By physical state we means solid state, liquid state or gaseous state. So on the basis of your the state, you have 8 colloidal system. Physical state के basis पे. Second is on the basis of nature of interaction between the dispersed phase and dispersed medium. In colloidal solution we'll always talk about dispersed phase and dispersed medium. Okay? These are the two important words which represents the one which is in lesser amount or the one which is suspended in the dispersion medium. Okay? So interactions के basis पे there is one classification which says your colloids can be lyophilic or lyophobic. And there is third classification, which is on the size, on the type of the molecule, which is associated colloids. Sorry, the type of the molecules which under which you have three kind of colloids: multimolecular colloids, you have macromolecular colloids, and you have associated colloids. So we'll start with first classification, which says on the basis of physical state. Write down: on the basis of physical state of dispersed phase and dispersed medium. Now I want you to tabulate it. Let me say I write dispersed phase as dP. Okay, this will do now. Dispersed medium. Then you have the kind of colloidal solution you are getting, but we are going to call that colloidal solution, and we'll see some examples also. Okay. First is, let me say your dispersed phase is present in solid state. S means solid state, and your medium is changing from solid to liquid and gaseous state. Okay, you have your dispersed phase in solid state and you are changing your medium. When you are making them mix, when your dispersed phase is solid and your dispersed medium is also solid, what you will get? You will get solid sol. Okay, you will get solid sol. When your dispersed phase is solid and dispersed medium is liquid, what you will get? You will get gel. When your dispersed phase is solid and you get gas, what you will get? Aerosols. Coming to the example, solid के अंदर you have colored glasses and gemstones. These are some of the examples. Okay. Gel के अंदर you have paints and cell fluids. Under aerosols you have smoke and dust. Okay. This is when your dispersed phase is in solid state and your medium is changing from solid to liquid to gas. Now when your dispersed phase is liquid and your medium is changing in the same way, solid to liquid to gas. When you are adding liquid to solid, you get a formation of gel. When liquid is interacting, you get emulsions. And when you add liquid to a gas, you get foam. Or you get aerosols. Okay. Sorry? Solid and gas. Dispersed phase is liquid and dispersed medium is in gaseous state. This. We're talking about this. This is solid state, this is gaseous state. You get aerosols. No. Okay, this is aerosols. You'll get aerosols. Okay. Coming to the examples, in case of gel, you will have, when liquid is added to a solid, you can write down cheese, butter or jellies. Okay. They comes under your emulsions. Mein what you will have? Milk, creams. Aerosols mein you will have what? Any examples from you? Fog, mist, clouds. Okay. Last is when you have your dispersed phase in gaseous state. And your medium is changing again from solid to liquid to gas. When gas is added to a solid, what you will get? Solid sol. When you add gas to a liquid, what you will get? Foam. When you add, this is gas. When you add gas to a gas, what you'll get? Homogeneous mixture. That in that case you won't call that to be a colloidal solution. So you have no colloidal solution because that is a homogeneous mixture. You cannot distinguish between the two phases. But this is like your dispersed phase, this is your dispersed medium. Okay. Solid soul के अंदर you can have an example, your pumice stone. That is an example of your solid soul. Foam. Foam के लिए example, froth, whipped cream. They come under your foam categories. Okay. We'll be doing this emulsions and our sols in details. Okay, sols, emulsions and gel, they are important to us. One important thing I would like to mention here is that depending upon the kind of a dispersion medium, you are going to name your colloidal form. For example, when your dispersion medium is water, you are going to call that as aquasol or hydrosol. If your dispersion medium is alcohol, you will call that as alkosol. If your dispersion medium is benzene, you will call that benzosol. If your dispersed medium is gas, you will call that aerosol. So by changing the type of dispersion medium, your classification is changing. Okay, so just by looking at the word hydrosol, aquasol, you can say dispersion medium is water. Alkosol means dispersion medium is alcohol. Aerosol means dispersion medium is gas. Okay. Out of all these sols which we have discussed, three are very important to us. One is sols, which is solid is getting dissolved in or getting added to your liquid. Second is gel, liquid is added to a liquid. Third is emulsion. Emulsion means liquid is emulsion. Gel means you are adding solid to liquid. So these three kind of colloidal solutions are very important and we'll discuss them in details. Okay, so starting with sols, the first, okay. So on the basis of the kind of physical state, what we have seen, you have 8 kind of a sol. You can count 1, 2, 3, 4, 5, 6, 7, 8. Last is not possible because gases mix with the other gases in a homogeneous manner. You won't distinguish between the dispersed phase and the dispersed medium. Second difference is on the basis of the interactions between the dispersed phase and the dispersed medium. You call your colloidal solution to be lyophobic and lyophilic. Okay, so write down on the basis of the interactions between the dispersed phase and dispersed medium, you call your sol to be lyophobic and lyophilic. Lyophilic and lyophobic. Okay, interactions between dispersed phase and dispersed. Let's start with first. By the term lyophilic means solvent loving. Okay, they are solvent loving. Lyophobic means they are solvent repelling, or you can use one more word also, that is they are solvent haters. They don't like solvent. Okay, first is on the basis of this you can call this to be solvent loving, that is solvent hating or solvent repelling. Second difference is how you can prepare them. Lyophobic sols can be prepared easily, that is like you can just add gums, raisins into the dispersion medium and you just shake that mixture. You will have your lyophilic sols. They can be synthesized easily, but that is not the case with your lyophobic sols. There are special methods which are used for the synthesis of your lyophobic sols. So you can say they can be synthesized easily. There are certain kind of special methods required for the synthesis of your lyophobic sols. Since the lyophilic sols are synthesized easily, they are reversible in nature. Let me say you take gum resin. Gum is like dissolved in water. You heat it. Water will evaporate. You can have your gum in a concentrated form. You add water again to it. You can have your sol back. But you cannot do the same thing with your lyophobic sol. Once you heat the lyophobic sol, that sol become disturbed. ठीक है? It will lead to the precipitation of the soul. That soul will become unstable. It will lead to the precipitation of the soul, and that soul will coagulate. That colloidal particles will get settled at the bottom, and you cannot have that back by just adding dispersion medium. So you can say they are stable, lyophilic are stable, and lyophobic are unstable. Lyophilic are reversible in nature, whereas lyophobic are irreversible in nature. Okay? They are reversible because they are easy to synthesize. Okay? I should stop. Okay. इनको ये टॉपिक तो कंप्लीट करा दो, ये तो है ना, बाकी लाइव यू कैन लाइक just to complete this I need 5 minutes. They are reversible, they are not reversible. ठीक है? They are reversible, they are not reversible. Easily synthesized. ठीक है? Process is simple. Special methods are used, which we'll discuss in details. Okay? Since they are reversible, easy synthesized, they are stable in nature. They are not stable. To make them stable, you need stabilizing agent. Stabilizing agents are needed so that you can have a stable lyophobic colloidal soul. Okay? And one more thing, when you use water as a medium, you can call your soul as hydrosol, hydrophobic and hydrophilic solution. Hydrophilic, lyophilic water use करेंगे तो you'll call it as hydrophilic, और lyophobic बनेगा तो you'll call as hydrophobic. Hydrophilic means water loving, hydrophobic means water repelling. Okay? Hydrophobic के अंदर आपके वो soaps and detergents आते हैं, which are water repelling substances. With this, your second description is over. Thank you. I don't know, time over हो गया.